Good morning, friends. Myself, Dr. Yogesh Balwant Rasala, working as Assistant Professor in Amolak Science College, Kada. Today, we are going to discuss basic concept of classical mechanics. So, what is classical mechanics and what are the basic fundamental laws of classical mechanics that we are going to study? In introduction, we can say that classical mechanics is that mechanics in which the study of motion of macroscopic bodies are done, and vice versa in quantum mechanics study of mechanics or motion of microscopic bodies are done in quantum mechanics. So what is the major difference between microscopic and macroscopic bodies? So microscopic bodies that are not seen by our naked eyes, and macroscopic bodies are that bodies which we can see by our naked eyes. So what are the examples of macroscopic and microscopic bodies? So microscopic bodies are those bodies which we cannot see by our naked eyes, and the examples are electrons, protons, neutrons, positrons, mesons, etc. And macroscopic bodies are that bodies which we can see by our naked eyes. So what are the examples of macroscopic bodies? The examples are big machineries, truck moving on the road, aeroplane flying in the sky, solar system, spacecraft, stars, planets. These are all examples of macroscopic bodies. So earliest development was made for classical mechanics, and the fundamental laws of classical mechanics are of or it is called as also Newtonian mechanics. And the fundamental laws of Newtonian mechanics are Newton's laws of motion, Newton's law of gravitation, and Kepler's law of planetary motion. So these three are fundamental laws of classical or Newtonian mechanics. Earlier it is called as Newtonian mechanics because the all fundamental three laws are developed. These are fundamental laws of Newtonian mechanics that we will see the details of these laws. The Newton's laws of motion are also divided into three different laws based on their concept and properties and action. So, law of inertia is the first law, and it is an object in a motion tend to remain in motion, or an object is at rest remain at rest for a long while. So example of this is if we keep suppose one book on a table, and if we lock this a room and we go away from this, and after 5 days if we come, then it is observed that the book is remain at rest position and it does not displaced by its position. So this is the first. And what is the second way? That is, if a body is in motion. Okay. If we take an example of solar system, continuous body is in motion. Okay, for a long while, continuous for a long time, it is in motion. So these are two examples of this force law. For an it is already explained by the definition as a force. So it is force is equal to mass into acceleration. Force is product of mass into acceleration. So this is the second uh, law, that is Newton's law of motion. And third one is a conservation of momentum law. That means for every action there is an equal and opposite reaction. If we take a two particle, then particle 1 exert force on second particle as F21, and particle 2 exerts force on particle 1. So both particle exerts a force, and the it is given by F12 is equal to minus F2n, because there is opposite direction is there, equal and opposite. So this is a minus sign is there in that equation. Then the second fundamental law of Newtonian mechanics is Newton's law of gravitation, and this law states that every point of mass attracts every other point of mass by a force, and this force is attractive force, and this force acting along the line of intersecting of the two points, and it is given by, it is directly proportional to product of their masses and inversely proportional to the square of the distance between them. And third fundamental law of Newtonian mechanics is Kepler's law of planetary motion, and again these Kepler's laws are divided into three different laws. So first law is sun is situated at a single position and all planets revolve around sun in an elliptical orbit. Then there is second law. Second law states that an every equal interval of time, planet sweeps equal area. So every time if sees there is a radius is large, then in equal interval of time that particle displaces on the curvature path, the distance is very less. But when the radius is less, in the same equal interval of time, the particle displaces more on the curvature path. So both the areas are same, because in first case radius is large, displacement is less. Whatever area sweeps under this area, two radius vectors, this is same as that of this, because here r is less but the displacement is large. So this two radius vector sweeps equal area as that of these two radius vectors. And third law is the square of period of revolution is directly proportional to cube of semi-major axis. So semi-major axis and semi-minor axis, these two axes are there. Semi-major axis is along x-axis, semi-minor axis is along y-axis, and this measures a value, and on y-axis this measures b value. So this and square of period of revolution, we know that time required to complete one rotation, one revolution is called as period. So this square of period of revolution is directly proportional to cube of semi-major axis. These three laws are fundamental laws of Newtonian mechanics. These two fundamental laws are developed in 18th and 19th centuries. But so in a classical mechanics, there are more different scientists who studies continuously and developed many more theories and fundamental laws to calculate the motion of the object. So these are nothing but a Lagrangian and Hamiltonian mechanics. These are two scientists who developed some theory to define some mechanism to define the motion of the macro type of bodies. Initially, these are valid for all micro and macro type. There is no such a difference. But after some days, as time passes, the different scientists are studying the different problems. That is like a general theory of relativity. Einstein studies this, discovered this black body radiations, and also Max Planck used to describe quantum hypothesis. So see, these all three laws of Newton mechanics are not valid in these such examples of general theory of relativity, black body radiation, radiation, then quantum hypothesis like electron motion in a copper wire, copper metal. So these Newtonian laws are not valid in such examples. So the quantum mechanics is developed, and the separate branch of physics was produced, that is called as quantum mechanics. This mechanics studies for micro type of bodies. Now, to study the mechanics means what exactly we want to do here. So, the way to study the mechanics for a particle, that is divided into two. For a single particle, there are some different laws, different formulas, different concepts, and for system of particle, there are different fundamental physical properties. So, what exactly to study the mechanics is that we are going to discuss here. So single particle, we know that we are observed here, a blue spot is a single particle. It has if we apply force to that particle, it displaces by some distance. It has linear velocity, it has linear momentum, it has kinetic energy, it possesses potential energy. So these different parameters are applied to that single particle. And again, a system of particle, that means there are more than one particles are there present in the system, and these all particles are continuously in a motion in the system. If we apply force initially to that system, then it produces, or it is called as system of particle. So we are going to discuss mechanics for single particle, and we are going to discuss this mechanics for system of particle. That means more than one particle are there in the system. So to study this mechanics means what? To find out the equation of motion for a single body and for more than one body, to find out the force acting on that body, to find out the momentum, to study the center of mass, to find out kinetic and potential energies, to study conservation of momentum and energy. So all these activities that we are going to discuss for single particle and for system of particle. So this is the very important concept for single particle. Or there are two types of momentums are there. If body is moving in a straight line, that body possesses linear momentum. Okay, and if body is in a moving in a circular path, then that body possesses angular momentum because it is displaced by angle. And if body is in a straight line, it is displaced by distance itself. So displacement variations are there. So if a body is having m mass, it is moving with velocity v in a straight line, then that body have a linear momentum. It is defined by equation p is equal to mv. So this is about linear momentum, and now this linear momentum p is equal to mv. These vector quantities are there, p and v. We know that the dimension of momentum are ml by t, because here v is equal to dx by dt. So m having m1, x having l1, and by dt having by t. So this is the dimensions. So SI unit of the momentum is kg meter per second, and this momentum can be expressed in three different component forms. We know that if body is moving along x-axis, it has a velocity vx, and it has a momentum px is equal to mvx. And if body is moving along y-axis, then that body having a velocity vy, and that body possesses a py momentum, similarly to that of along z-axis. So thank you. We'll stop here. In next lecture, we are going to discuss mechanics for single particle. That means we are going to discuss all these points we have seen in the last one slide, and that all points we are going to discuss for single particle separately and for system of particle separately. So we will stop here. Thank you.